All right, good morning or good afternoon. Welcome to, or good evening, depending upon what part of the country you are in or the world you are in. My name is Thomas Dimitrovich, and welcome to another session of IAEI News Live. Today, we are going to continue our discussion and hopefully finalize our discussion around lighting and the NEC, and it all starts now. All right. Okay, so hopefully everybody out there is doing well. This is a recorded session. Again, I have to apologize again. I'm in DC today and at a NEMA Codes and Standards meeting. So today I do want to make sure we get through all of our areas of discussion around lighting and the NEC. And hopefully you're getting something out of this series. We left off yesterday talking about the differences between HID circuit breakers, high intensity discharge lighting for lighting 50 amps or less, circuit breakers rated 480 volts or less, and those breakers that are marked for HID, what their capabilities are. And I believe we looked at the UL 489 standard testing requirements for those circuit breakers and helped you understand the reasons why and what is different with regard to the testing. Now, I know we had one question that came up on how are these circuit breakers constructed differently, and the first thing I want to say is every manufacturer of circuit breakers will do something a little different to meet the requirements of the testing that is placed upon them based on the UL standards. And what do we know about some of this about the test? Let's just refresh our memory, because there was a good question, and I don't want to skip over that discussion. So now remember, the UL standard 489 for circuit breakers is requiring us to have endurance test in accordance with 7.1.5, except, so I'm doing these endurance tests, but I'm also doing them with current passing through them at a power factor in a range from 45 to 50%. Now, just think about what that means for a circuit breaker. When current is flowing through the contacts of a circuit breaker, when I separate, or when the circuit breaker, not me because I'm not a circuit breaker, when a circuit breaker separates its contacts to stop the flow of current, the easiest point on the sine wave to get that done is when you're at a zero crossing. The worst point to get that done is when your current is at a peak. So, and even worse yet is when my current is at a peak, but my voltage is zero. Because now you have a difference of phase relationship in what's going on. And remember, a lot of these circuit breakers are going to be, if they're on a lighting circuit, it's all lighting. It's not like you'll say a certain percentage, especially if you're using the circuit breaker to turn the lights on and off. That's the other application consideration important when we're testing circuit breakers. So when the power factor, the hardest time for a circuit breaker to stop that flow of current while we're opening and closing those devices is when the power factor is low, like 45 to 50%. Lower than that, it gets very difficult for the circuit breaker to do its job. And think about what happens. You're drawing an arc. It's going to be probably a little bit more violent. And the contacts of that circuit breaker need to be able to handle the exposure that we're giving it. So what I might do differently, maybe the contacts on the surface, the materials that I use might be different. I'm not saying that that is a fact, but I'm just thinking from understanding the physics, understanding what is going on in the separation of those contacts and the arcs that we're drawing. You want to make sure you don't degrade the contacts. What are the things that circuit breaker manufacturers want to avoid? Or any manufacturer of a contact device. You don't want what they call dimpling. What dimpling is, if I, for example, had a dimple on my circuit breaker contact, and instead of closing and creating a contact along the entire surface, I'm only connecting on that dimple or multiple dimples. All my current is flowing through one point and not through the entire surface. And what that does is it generates, and I'm over-exemplifying, obviously, that generates a lot of heat going through a very small portion of material, which is ungood. Heat generated needlessly can only result in some bad things. So those are the tests and whatnot that we are going through when we are testing our circuit breakers for those types of lighting configurations, and they are not unity power factor. That's an important part because of what I said last week. When we got into the changes that we see in Article 220 for load calculations, we made some changes in the VA per square foot, not the watts per square foot. Because we don't size equipment based on watts, we size the equipment based on VA. So table 220.12, we had this discussion considerably in length, that what we're dealing with is watts and not VA. And these lighting solutions do not have a unity power factor like we're used to with incandescent lighting. So we talked about SWD breakers, switch duty breakers. We talked about HACR hacker rated breakers, which we don't use that anymore. All right. And so now we're going to get into the next question. So let's do this. Okay, 240.83. 240.83 includes requirements for circuit breakers used to switch fluorescent and HID lighting circuits. Does the NEC, other codes or engineering principles require the same concern for incandescent or LED lighting circuits? I know what, some of these, the reasons why they're posed. So 240.83, open up your book, and again, just in case, National Electrical Code 2020 version of the NEC is the document that I'm using. And remember, although I sit on code making panels 2 and 10 for the development of this book, I do not speak on behalf of code making panels 2 and 10. I do not speak on behalf of NFPA. I do not speak on behalf of IAEI. What comes out of here was generated here, nowhere else. Based on experience, based on everything and don't believe half of what you hear and less of what you see. Always question everything from everybody until you completely understand it. And have that dialogue. I'm not always right. No one is always right. So, except one guy. He's not around anymore. Spiritually, he's here, but anyway. 240.83. Keep that in mind as you watch all of these programs or any program you see on the web. Now, 240.83 is in Part 7, which addresses circuit breakers. And remember, Part 7, if you go back to 240.1, the scope, it says Parts 1 through 7 of this article provide the general requirements for overcurrent protection and overcurrent protected devices not more than 1,000 volts nominal. So we're in Part 7. We know this is not more than 1,000 volts nominal, and we are looking at 240.83. So just remember, it puts your mind into perspective. It's important to follow these principles until you get it. I sometimes forget. So, because I'm not in this, I mean, I'm in this book quite a lot. I mean, if you watch online, but every now and then you know, and I know I'll do this. I'll say something and I'll go, why the heck would I say that? I know better than that. I know I'm blah 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 blah. But it's important to go through the process. So we know we're in Part 7, circuit breakers, 1,000 volts or less. 240.83 says, and the 240.83 is titled marking. And, well, we've got marking. So we say includes requirements for circuit breakers, HID. We got marking requirements for durable and visible. We got location, 100 amps or less. We got interrupting ratings. We got circuit breakers used as switches. So let's take a look at that. And this is 240.83, D as in David. Circuit breakers used as switches in 120 volt and 277 volt fluorescent lighting circuits, they're requiring them to be listed as SWD or HID. Circuit breakers used as switches in high intensity discharge lighting circuits shall be listed and shall be marked as HID. We just talked about this, right? We just talked about this. So UL 489 for circuit breakers does not include any special testing for LED lighting loads. So from an LED perspective, there's no, we have HID breakers for high intensity discharge. We've got SWD for switch duty. We don't have LED for lighting emitting diode technologies, circuit breakers. So now what I do know is I've heard people talk about the fact that if they put too many LED lights on a circuit, single circuit, that when they energize the LED lights, they have tripped the molded case circuit breaker. And that is purely because of inrush currents. It doesn't have anything to do with whether or not there were GFCIs in there. I mean, I've heard this on standard thermomagnetic circuit breakers. And the reason that is the case is because these are types of circuits that will produce inrush currents, and they don't persist. They're short duration enough, though, to trip a molded case circuit breaker on instantaneous. Now, I'm not aware of, and you guys and gals can comment, because please comment down below. Do you have principles of how you design and lay out circuits with regard to, say, LED circuit breakers? Now, I'm just looking, I just did a quick search. I don't know if you have any words of wisdom. I have not. All I can tell you is that I have seen and I've heard of people who have had a tripping issue when they've had a lot of LED lights drivers, LED drivers on the same circuit. I can't give you any industry recognized guidance in that regard. But the inrush currents can be very large. And I believe my suggestion would be that you should consult the LED manufacturer to understand what those inrush currents are. And then if you consult the driver manufacturer, and I don't know where it's going on in my head is, I mean, do I want to say you should contact the circuit breaker manufacturer? I mean, we publish trip curves, right? So you could look at the trip curves of the circuit breaker, take a look at what the inrush currents are, and assume you're all turning them on all at once, because not all of these circuits will the LEDs be turned on all at once, the drivers, but it very well could be. Places where I know there's heavy use of LED circuits are these grow facilities, right? Commercial buildings might use a lot of LED drivers in a string on the same circuit. So I think what my suggestion would be, understand the inrush currents. That's the number. That's the data point you're looking for on these circuits, for these types of loads, and then consider how many you have. And worst case solution, consider they're all turning on at the same time. That will give you some ideas. So that would be my suggestion. I would say take a look at the driver itself, talk to the manufacturer, understand what types of inrush currents can be expected by those drivers. Remember, the actual LED is on the DC side, so there's no inrush currents on the DC side. Don't say what's the inrush current on this LED light. You want to know the inrush current on the driver, because that's where the AC to DC occurs, and it's an inductive circuit. So, and that's why we have poor power factor in association with these solutions. All right, so that's sort of my discussion on that one, and that's all I have to say about that. Are specific types of dimmers required for various types of lighting, incandescent, fluorescent, HID, or LED? All right, so I've experienced this one personally. We all have those learning experiences where you do something, install something, and you think it's going to operate one way based on what you know, and you find out it's not acting that way. So a little bit of coffee, and it goes a long way. Now, we already know that each type of lighting load will have characteristics. What have we talked about so far? We talked about the fact that there is HID, high intensity discharge lighting. It will have a current signature of current draw with a power factor that we need to consider when we select our overcurrent protective devices. We know there are requirements around that. We know, and we've talked about, compact fluorescence and fluorescent lighting. Its current signature, its current draw. And we know that I need a special breaker if I'm going to use that circuit breaker as a switch to turn on fluorescent types of lighting solutions on and off. We also just got done talking about the fact that LEDs could have inrush currents, right? The drivers have inrush currents that may impact the performance of your circuit breaker that's protecting that branch circuit. If we would think that dimmer switches and other types of controllers for that lighting solution wouldn't have to take into consideration similar properties of those lighting solutions, I think we would be mistaken, right? So UL standards for these types of solutions do take that into consideration. So incandescent halogen lights, resistive loads, rated for cold filament inrush, positive and negative periods may be equal. They don't use magnetic low voltage or electronic low voltage type of solutions. Magnetic low voltage. So it's a magnetic core and coil, like a toroid. It's a transformer supply low voltage lighting. So the actual lamp would be of a lower voltage, 24 volts, 6 or 12. These are inductive circuits. We already said that, right? They have a smooth turn on and off. Positive and negative periods are equal. On that sine wave included transformer losses when calculating the load. You've got your electronic low voltage. So solid state transformer supplied low voltage lighting. These are capacitive types of loads. Very smooth turn on and off. You've got neon cold cathode. These are your magnetic ballasts. Very inductive loads. Symmetric cycles, voltage DC less than 2 VDC. The smooth turn off, so equal for the MLV transformer operation, include transformer losses when calculating the load, low end trim capability. Then you get into fluorescence. Special dimmers are designed and UL listed to send power and control signals to each type of electronic fluorescent dimming ballast. Now, I've had, in one case in my basement in a previous home, I replaced all of my lights in my basement with, I believe it was compact fluorescence. And I felt I was like in the 70s, I was in a disco scene. They were just going all over the place. And I did my research on that, and it was my selection of my, and it was an occupancy sensor that when I walked in the room, it would turn on the lights automatically. It was not compatible with the fluorescent. I would have had to purchase a different switch, occupancy sensor switch. So I had to change that out for, actually what I did was, the easiest thing for me was to change the lamps to standard incandescent bulbs, which is what I did. Rather than go back out to the store, buy another expensive occupancy sensor switch. So it was a compatibility between these two products, and I had to buy a specific listed switch for that application. LEDs. Special dimmers are designed to send power and control signals to each type of electronic LED driver. LED light source must be properly matched to the LED driver, and the driver must meet control specifications for control type. So, depending upon the technology that's on that branch circuit, I have to think about my overcurrent protective device compatibility and listing, and I do have to think about the listing and compatibility of my dimmer switches, occupancy control switches that are listed to be used with those applications. So, dimmer switch for what do we say? So, fluorescent lights. I'm just going to do I'm just doing a quick search. And let's see what we come up with. Using a dimmer fluorescence lamp, anylamp.com. We got do it yourself. Let's I'm just going to take a look at I'd love to find a cut sheet. So there's incandescent dimmers, there's fluorescent dimmers. I'm going to grab fluorescent dimmer. I don't know what manufacturer, I don't care right now. I'm just looking for a cut sheet. Here we go. So here we go. So I don't know. This happens to be a Leviton. So let's take a look at what they have to offer. Fluids, captive wraparound side, compatible with dimmable LED and CFL lamps. So it specifically calls it out. I'm going to see if there's anything in here. To gang. Incandescent dimmer. So here we go. Look at this. You have an incandescent dimmer with LED locator. LED CFL incandescent dimmer with no LEDs. So look, if you just look, fluorescent dimmer for Mark 10 power line ballast. LED dimmer, quiet fan speed control, fully. So when you look at the manufacturer's information, you'll find that you can purchase products listed for use for the type of luminaire or the technology that's used in the luminaire. I'm trying to be very careful and use correct language here. So be mindful of that. Be mindful of that and make sure that you pick the right solutions that are all of the solutions that are compatible. So you've got a listing requirement for the breakers. Let's just take fluorescence as an example. You've got a listing requirement for the breaker you're looking for. You have a special dimmer switch that you're looking for. And then obviously you have the luminaire itself. So, and you thought lighting was easy, didn't you? All right. Does the NEC include special requirements for luminaires used in indoor sports, mixed use, and all-purpose facilities? If so, are the requirements the same for all types of lighting? And if not, why? So let's do this. What article would you start with to answer this question? First article I would go to is 410. Would it be 410? Yes, I would go to 410. 410 is luminaires, lamp holders, and lamps. Okay, so does the NEC include requirements for luminaires used in indoor sports, mixed use, and all-purpose facilities? Well, luminaire locations might be a good place to start. Because the question's around locations. Wet and damp locations, corrosive locations, in ducts or hoods, bathtub and shower areas, luminaires used in indoor sports, mixed use and all purpose. Luminaires in indoor, okay, E. Geez, oh man. Whoever came up with that question used the title of 410.10E. Luminaires in indoor sports, mixed use and all purpose facilities. So does the NEC include special requirements for luminaires used? Well, duh. Luminaire subject to physical damage using a mercury vapor or metal halide lamp installed in playing and spectator seating areas of indoor sports. Well, we know what that's the issue there is, right? So if you have mercury vapor or metal halide, so mercury is a hazardous type of component, right? So if you're in this area, you know that you don't want to hit it. I mean, especially like basketball. You ever see me play basketball? Whew, man, that ball goes everywhere. So if I hit that lamp, if I hit the lamp, if I break the lamp, if I break the fixture, or I hit the fixture, and if I hit the luminaire, then I don't want stuff going everywhere, right? So it says, installed in playing and spectators seating areas of indoor sports, mixed use or all-purpose facilities shall be of the type that protects the lamp with a glass or plastic lens. Such luminaires shall be permitted to have an additional guard. Well, that was an easy one. So I would say yes. Metal halide lamp is an electric lamp that produces light by an electric arc through a gaseous mixture of vaporized mercury. And a mercury vapor lamp is a gas discharge lamp that uses an electric arc through vaporized mercury to produce light. You break them puppies, and you don't want that to shower over a group of individuals. So I would say yes. I don't know why I'm showing that picture, but that looks ugly. Who does that? And why am I showing this picture? All right. That is not good. You don't want to be wrapping the wire like that, right? That's not good. Kids, what are you going to do with them? All right, question 11. Does the NEC include special requirements for luminaires installed in closed closets? Oh. If so, are the requirements the same for all types of lighting? If not, why? Okay, so think about lighting in a closed closet. Flammable materials, probably all around it. So my guess would be one of the concerns would be heat and ignition. So those would be my two concerns. Now, special requirements for luminaires installed in closed closets. So I would be still looking in luminaire locations, part 2 of Article 410, I would assume. 410.10 is luminaires in specific locations. And if I go down through that list, luminaires near combustible materials. I don't know. Doesn't say closed closets, but I know I have combustibles. Let's look at what 410.11 says. Luminaires shall be constructed, installed, or equipped with shades or guards so that combustible material is not subject to temperatures in excess of 194 degrees Fahrenheit or 90 degrees C. All right, that might be a consideration, but it doesn't specifically say closed closets, so we got to, we say keep going. Keep going. 410.12 is luminaires over combustible material. If you've ever seen my closet, I've got more on the floor than I have on the rack. So let's look at that one. Lamp holders installed over highly combustible material. I don't know if clothing would be highly combustible. What is highly combustible material? Anybody out there? Put a comment down. What do you think highly combustible material is? And who defines it? All right, we're going to continue reading. Unless an individual switch is provided for each luminaire, lamp holders shall be located at least 8 foot above the floor, or shall be located or guarded so that the lamps cannot be readily removed or damaged. Okay. But does that still address our question about closed closets? Keep going. Luminaires in show windows. My closet is not a show window. It may be those items came from a show window, but it's not a show window. 410.16, luminaires in closed closets. All right, so I would expect that 410.16 comprises a little bit of 410.11 and 410.12 around luminaires being close to combustible materials. All right, so a substance, and I don't know if you, because I'm not live right now, and I'm sure somebody down below has indicated that a substance that is considered highly flammable if its ignition point is lower than 90 degrees Fahrenheit. Now, let's think about some items in a residential home that have an ignition point lower than 90 degrees Fahrenheit. Flour. Yes, flour can be a fire hazard, right? Because especially if it's like what do you call like in the air, powdery stuff, right? So you can ignite flour. Flour is ignitable below 90 degrees. Any of the beauty products. So if you're in your bathroom or whatnot, using hairspray and things of that nature, that's highly flammable. Paraffin-based skin creams, highly flammable. Hand sanitizer, cooking oil, nail polish remover, laundry products and detergents. Some of your auto products, antifreeze, obviously gasoline, right? Pool cleaning chemicals can be highly flammable. And then obviously, or not obviously, but your shoe polishes and things like that. Mothballs are very flammable and whatnot. So there are a lot of flammable, highly flammable products within a residential dwelling unit, or very combustible. I'm just looking to see if there are other types of. They give you a lot of like guidance on handling equipment and things of that nature. Clothing wasn't in there. Clothing. These clothes are most flammable. Let's try this one out. Structure of material makes a difference. Billowy cloths burn fast. Cotton, linen easily catch fire and flames spread readily. And we know that from 70E discussions. Polyester melts, right? But polyester and nylon melt rather than catch fire. So they pull away from the flame, all that jazz. So they don't combust. Acrylic is the most flammable of all synthetic fibers. It can be difficult to ignite, but once acrylic catches fire, it burns vigorously. Acrylic fibers melt and drip. This means that if an acrylic clothing catches fire, it may cause deep burns. Clothes made from wool and motocrylic are the least flammable. So wool pants easily catch fire. So cellulose fibers like cotton, linen easily catch fire and the flames spread rapidly. So cotton. So I would say clothes are in that cotton world. All right, so let's take a look at what 410.16 tells us. And there's an A, B, C. A talks about the luminaire types that are permitted, the luminaire types that are not permitted, and then the location. And all right, here we go. So look at this. So A, luminaire types that are permitted. Only luminaires of the following types are permitted in the clothes closet. Surface mount or recessed incandescent or LED luminaires that the light source is completely enclosed. A surface mount or recessed fluorescent luminaire, but it doesn't say anything about being enclosed. Surface mount fluorescent or LED luminaires identified as suitable for installation within closed closet storage space. Interesting. So that means that there's a standard somewhere that says that that equipment should be marked that way if it's tested for that. Luminaires not permitted. Incandescent luminaires with open or partially enclosed lamps and pendant luminaires or lamp holders not permitted. Don't put pendants. Now the location. Now location gets into the distances. And just like we saw earlier with 410.11, near combustible, we know distance is your friend, right? And we know 90 degrees C is an important number. And in whether it's over or near, if it's over, we saw the 8 foot above the floor. So let's take a look at what 410.16 tells us. 12 inches for surface-mounted incandescent or LED luminaires with completely enclosed light source. Installed on the wall above the door. The minimum clearance between luminaires installed in closed closets and the nearest point of a closed closet storage space. So these are distances between the luminaire and the closest storage space. 12 inches for a surface-mounted incandescent or a LED luminaire. And we know it has to be completely enclosed. If it's on the wall, above the door, or on the ceiling. On the wall, above the door, or on the ceiling. 12 inches. 6 inches for surface-mounted fluorescent luminaires installed on the wall above the door or on the ceiling. So fluorescence, you're allowed to put closer than LEDs. You have to have a 12-inch distance for LEDs, only a 6-inch distance for fluorescence. 6 inches for recessed incandescent or LED luminaires with a completely enclosed light source. Installed in the wall or the ceiling. I don't think I've ever seen a recessed light in a wall. I've seen them in ceilings. Anyway, 6 inches for recessed fluorescent luminaires installed in the wall. So I got 6 inches for incandescent or LED and 6 inches for fluorescent when they're recessed either in the walls or the ceilings. And then finally, surface-mounted fluorescent or LED luminaires shall be permitted to be installed within the closed closet storage space where identified for that application use. And my guess is the listing requirement requires the covering of those. So 410.16 is going to be a very important reference. I would also reference 410.11 and 12. And there is a figure 410.2 in the code. Because closed closet storage space is defined. That's an important piece of the puzzle. The definition of a closed closet storage space, because why? Why is that important? Because remember, it says in 410.16c, it said, the minimum clearance between luminaires installed in closed closets and the nearest point of a closed closet storage space. And that's why I hesitate when I read it. I'm like, what is a closed closet storage space? And that, my friend, is a defined term. Can this code make it any easier? I don't know. Let's read. The volume bounded by the side and back closet walls and planes extending from the closet floor vertically to a height of 6 foot or to the highest closed hanging rod and parallel to the walls at a horizontal distance of 24 inches. From the sides and back of the closed closet walls, respectively, and continuing vertically to the closet ceiling parallel to the walls at a horizontal distance, or the width of the shelf, whichever is greater. For a closet that permits access to both sides of a hanging rod, this space includes the volume below the highest rod extending 12 inches on either side of the rod on a plane horizontal to the floor. So, what's interesting, remember in 410.16, it kept saying the light source installed on the wall above the door or on the ceiling. Why didn't it say the wall, any wall, inside of a closet? And I think it has to do with how we define a closed closet storage space. And that image that is in figure 410.2. You see that indentation at the top would be above that door, wouldn't it? There's your rod height. There's your 24 inches. The volume bounded by the sides and back closet walls. The sides and the back closet wall. I'm not talking about the front wall above the door. And the planes extending from the closet door floor vertically to a height of 6 foot, or to the highest clothes hanging rod. This helps us understand the closet itself when you are placing any lighting within that space. Your safest bet is always just put a light in the center of the room to light the room. I mean, from a practical perspective, you wouldn't put it on the walls above, or try to put it on the walls above any of your clothes closet hangings, because then you wouldn't be able to see your clothes. The light's got to get around, right? Or you could try to put lights on both sides and do a cross thing there. But typically in closets, you've got a light right above you. I've seen in some very small closets where they put a light right at the top of the door because of the size of the closet itself. Might not permit a light in the center. Your larger walk-in closets will probably have a light in the center. Your smaller closets, if you want a light, it's going to be above the door when you first go into the closet. And it has to be listed for that application. Well, that was a fun one. Okay. The NEC indicates in 410.18, coves shall have adequate space and shall be located so that lamps and equipment can be properly installed and maintained. What does that requirement mean to designers, installers, and AHJs? And they want examples of permitted and not permitted applications. Would the requirement be the same for all types of luminaires? Okay, codes. I've got some pictures I've taken. There's a good one. Cove lighting, 410.18, right? Space for cove lighting. Coves shall have adequate space and shall be located so that the lamps and equipment can be properly installed and maintained. Wow, that's pretty vague. I don't know about you. But that's an example of cove lighting. There's probably an LED strip along the top. There's another example. This was in a restaurant, I believe at an NFPA meeting somewhere. You may recognize this. So there's your cove lighting right in this area here. Okay. That is a space, and the lights are located inside. So the language that's written, coves shall have adequate space and shall be located so that the lamps and equipment can be properly installed and maintained, is pretty vague. Pretty vague. So I think that that's an area that we need to consider. But because it's vague, it probably puts inspectors and contractors in a difficult situation. All right, so let's take a look at the next one. Are all luminaires suitable for installation in dry, damp, and or wet locations? Where is the dry, damp, and wet location markings located on a luminaire? Well, that's what it says right here. Surface fluorescent channel luminaire, Series suitable for damp locations. So it specifically says damp locations. Here's another one. Luminaires for hazardous locations when completely assembled with the fixture fittings. Suitable for wet locations, right there. Marine outside type, 4X. Says it right on the fixture itself. There's a wet location. That would not be a damp location. These, I would argue, probably are not wet locations. They're probably damp locations just because they're under the canopy. And this is a whole nother area of debate. What is a wet location? What is a damp location? You have to answer that question first before you start picking these luminaires, right? You've got to think about what is the location. Is it truly a damp location? Is it a wet location? What are the definitions? So if I look at the definition of a wet location, or damp location, location is you can't go to W, you got to go to location, comma, dry and wet and damp. So a damp locations protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. This would be a damp location. A wet location is installations underground or in concrete slabs or masonry in direct contact with the earth in locations subject to saturation with water or other liquids, such as vehicle washing areas, right? So that is definitely a wet location. This is a damp location. You need to buy and install the right luminaires for each of those locations. So look at number 14. How do designers, installers, and AHJs know when special installation requirements exist for orientation, connection, spacing from combustible materials, and air movement is needed for various luminaire types? Should we assume the needs and requirements vary from one luminaire to another? We have to rely on the manufacturer's instructions and the code. So if I look at 410.23, 410, let's go to 410, Article 410. Part 1 is general. Part 2 is luminaire location. Part 3, provisions at luminaire outlet boxes, canopies, and pans. You got temperature limits of conductors in outlet boxes to be covered, covering of combustible material at outlet boxes, any combustible wall or ceiling finish exposed between the edge of the luminaire canopy or pan and an outlet box having a surface area of 180 inches squared or more shall be covered with non-combustible materials. And spacings from combustible materials, 410.11, location, 410.12. If you've got it in a closed closet, 410.16, we just covered that in a previous question. 410.22, the covering. 410.23, covering of combustible material at the outlet box. .24, connection of electrical discharge and LED luminaires. The electric discharge in A says independent of the outlet box. Access to boxes, electric discharge and LED luminaires, surface mounted over concealed outlet, pull or junction boxes, and designed not to be supported solely by the outlet box shall be provided with suitable openings in the back of the luminaire to provide access to the wiring in the box. So outside of a few areas within the code, like 410.23, 410.11, 410.12, 410.16, grounding in Part 5. Part 6 is wiring of luminaires. Well, there was a new requirement in 410.70 as part of the 2020 code. Combustible shades and enclosures, airspace shall be provided between lamps and shades or other enclosures of combustible material. That's new for the 2020 code. Also new is 410.69. Identification of control conductor insulation. Where control conductors are spliced, terminated, and connected in the same luminaire or enclosure as the branch circuit conductors, the field-connected control conductor shall not be of a color reserved for the grounded branch circuit. This requirement, okay, that doesn't have anything to do with this one, but it was new. Just thought I'd say it. So that's 410.70 is a good one. Okay, let's keep looking for requirements that might be impact this. Okay, luminaire ratings. Nope. Portable luminaires. Installation of lamp holders. Screw and shell type lamp holders of the screw and shell type shall be installed for use as lamp holders only. Lamp holders near combustible materials. So this is in part 8, installation of lamp holders. Lamp holders shall be constructed, installed, or equipped with shades or guards so that combustible material is not subject to temperatures in excess of 90 degrees C, 194 degrees Fahrenheit. So there's another area. Installation in part 8, installation of lamp holders. Let's keep going. Part 9 is lamps and auxiliary equipment. 410.104 says electric discharge lamp auxiliary equipment enclosures shall be enclosed in non-combustible cases and treated as sources of heat. So 410.104a is another reference, right? And this is based on various luminaire types. Part 10, let's take a look at part 10. Special provisions for flush and recessed luminaires. 410.115 says temperature, combustible material, luminaires shall be installed so that adjacent combustible material will not be subjected to temperatures in excess of 194 degrees Fahrenheit. So that's 410.115a. Recessed incandescent luminaires, 410.115b. Incandescent luminaires shall have thermal protection and shall be identified as thermally protected. That will turn that lamp off when it gets too hot. So clearance and installation. This is just 410.16, which is in special provisions for flush and recessed luminaires. So in 410.16, clearance, they got non-type IC, type IC, they got installation. So A is clearance for non-type IC and type IC. And then B is installation. Thermal insulation shall not be installed above a recessed luminaire within 3 inches of the recessed luminaire's enclosure, wiring compartment, ballast, transformer, LED driver, power supply, identified as the type IC for insulation contact. So this is where I think many like homeowners, the do-it-yourselfers, get hurt. These types of details are not typically known by many. And a do-it-yourselfer who wants to replace or put in a can light, very easy to pick the wrong can, to pick the wrong luminaire and put it close to combustibles. That's ungood. Okay, 410. So then we go to part 11, construction of flushed and recessed luminaires. You've got you have temperature. Luminaires shall be constructed such that adjacent combustible materials not subject to temperatures in excess of 194 degrees Fahrenheit. You got lamp and wattage markers, lamp holders. That's part 12. Special provisions for electric discharge lighting systems 1,000 volts and less. This is your electric discharge lighting. Thermal protection, fluorescent luminaires. The ballast of a fluorescent. This is in 410.130e. The ballast of a fluorescent luminaire installed indoors shall have integral thermal protection. Replacement ballast shall also have thermal protection integral with the ballast. High-intensity discharge lighting. You have thermal protection required for recessed remote ballasts. Has to have thermal protection, shall not be required in a recessed high-intensity luminaire whose design, construction, and thermal performance characteristics are equivalent to a thermally protected luminaire and are identified as inherently protected. Recessed high-intensity luminaires designed to be installed in wall or ceiling cavities shall have thermal protection and be identified as thermally protected. Stuff, it just keeps getting better and better, right? So the way you have, if you just look at the overview of Article 410, you'll notice that each of these parts, you have decorative lighting and similar accessories in Part 15. 14 is lighting, track lighting. 13 is special provisions, electric discharge. So each of these parts covers types of luminaires. And that helps us understand what the capabilities and how to properly install them, especially in relationship to combustible materials, right? That's an important aspect of proper application of luminaires. All right, we're going to do one more question. Are all luminaires suitable for cord connection? If not, how will designers, installers, and AHJs know the limitations of the specific luminaire? So 410, so we're going to go to 410. Now, where would we go? 410. 410. Wiring of luminaires. So are all luminaires for cord connection? So I would say wiring of luminaires. Cord connected lamp holders and luminaires, 410.62. Where a metal lamp holder is attached to a flexible cord, the inlet shall be equipped with an insulated bushing that, if threaded, is not smaller than a trade size 3/8 inch pipe size. The cord hole shall be of a size appropriate for the cord, and all burrs and fins shall be removed in order to provide a smooth bearing surface for the cord. The bushings have to have a 9/32 inch in diameter, shall be permitted for use with a plain pendant cord and holes 13/32 inch, 11 millimeters in diameter with reinforced cord. They talk about adjustable luminaires. Luminaires that require adjustment or aiming after installation shall not be required to be equipped with an attachment plug or cord connector, provided the exposed cord is suitable for hard usage or extra hard usage and is not longer than the required for the maximum adjustment. C, they talk about electric discharge and LED lights shall comply with 410.62C1, cord connected installation. So there's a whole section here, 410.62, that help us understand the proper use of that. Now, if I look at the UL standard 496 for lamp holders, section 2.3.5 says lamp holder pendant type, a lamp holder intended to be cord supplied and suspended by a flexible cord. Here are some of the requirements associated with that. The cap of a pendant type lamp holder shall have provisions for strain relief, such that the pull exerted on the flexible cord is not transmitted to the wiring terminals. A hard fiber shall be acceptable as an insulating material. So we have standards that have requirements in 496. They talk about the cap and the shell, the types of solutions, and they have the thicknesses as well in here. And a lot of these will be transferable. There's your 194 degrees, right? An insulated bushing shall not soften at a temperature of 194 degrees. Hot molded shellac or tar composition shall not be used in insulating bushings. So there's your 410.62, and you have those requirements in 410.62. So here are just some images, right? There's a flexible cord going to that luminaire right up here at the top. And you'll notice the strain relief. You'll notice there's a strain relief right in here. That's holding this, and the cord does not have tension on it whatsoever. There's your examples again. Right now, the cord is on that strain relief, so the cord is not holding the luminaire up. This is mounted. This one here is actually, that's a cord plug connected, but this fixture is actually mounted to the ceiling. Now, I'm not sure about this one. I mean, who would put a chandelier in that location? But, you know, I don't know. Proper use, you got to make sure it's listed for the application. Look at this one. Well, is that a proper application? I think not. That SPT2 cord doesn't look good. How about this one? What helps us prevent installations and misuse? What helps us prevent that? The beginning of 410 helps us. In 410.6, listing required, all luminaires, lamp holders, and retrofit kits shall be listed. Hopefully, this journey through the luminaire and the code and that relationship and all of these items that we've discussed, these last three, this is the final part of luminaires and the code. I've got a lot more, there are a lot more items to be covered in the proper application of luminaires, but we could go on for days. I would hope that when you think about luminaires, that your takeaway from this discussion is that the luminaire is, it's not a simple installation as one would think. There are a lot of things to think about. The first step is to recognize you have a listed product. You're not dealing with a homemade solution that you have to worry about all of the details associated, especially if it was something that incorporated cords that are hanging down, supporting the lamps. So there are a lot of things you need to think about with regard to the proper application of luminaires. Combustible materials is one of them. The distances from combustibles, how they are mounted, where they are mounted. The relationship between the luminaire, the switch, and the overcurrent protective device. All of these things add a little complexity. Whether or not a luminaire is a continuous load or not. How do you do the load calculations, including luminaires? Are we considering VA and not just watts? Did we understand that power factor of a lot of these solutions are not unity, like the incandescent bulb? There are a lot of aspects associated with luminaires that go far and beyond of just going out to the shop, buying one, or picking one off the shelf and slapping it on the wall. It's more complicated than you think once you dig into the details. So don't forget, please subscribe. I got to put one over here. Don't forget to subscribe and hit the bell for the IAEI News Live and for all the other options that we have and considerations. We're growing our followers on our YouTube channel. So thank you for all that you're doing in that regard. Get the word out. Hit the subscribe out here on YouTube. Important that we get our followers up. We want to get to a certain number so that we can start doing some more amazing things through our YouTube presence. So don't forget Rudy's events, his monthly events as well. I believe he's changed the name. If you have not been watching, then excuse me, if you have not been watching, then you are missing something special, because Rudy's, I'm trying to think of, he just made a change. So I got to go out to my channels, and I've got to go to the IAEI's YouTube channel. Rudy's Roundup. Now, if you have not tuned into Rudy's Roundup, you got to. Those sessions provide a lot of good insight on what's going on at the IAEI and all the great things that team is doing to help increase electrical safety, to help provide areas, umbrellas that we can all communicate under, which is around electrical safety. Knowledge is powerful. Nobody can take that off you. So you can learn a lot through the IAEI and your engagement and involvement with that organization. So in addition to subscribing to this channel, this YouTube channel, get out there and get an IAEI membership and get involved with your local chapter. You can go to IAEI's website, find the events and meetings that are near you. Get out there, see who's going. You might be surprised who you see in the audience. Build the relationships that will last a lifetime. I'll look forward to seeing you at the next IAEI in-person meetings as well. Get out there to the section meeting. Don't forget the Western Section's registration is now live and open. So go out there to the Western Section site and purchase your ticket for the Western Section meeting, which is going to be in South Dakota. So look forward to seeing you at one of those. Thanks for joining in on this part 3 of IAEI News Live, continuing our discussion on lighting. I really look forward to seeing you next week and the week after and the week after and the week after. So remember to stay safe. Well, first, thank you for what you do for the electrical industry. Thanks for what you do, especially for electrical safety. Together, we are making a difference. I know it, I feel it, and I see it in the numbers. Thank you for what you do for electrical safety. Remember to stay safe, and please stay healthy. Until next week, take care.